Alright, hey guys, it's Mr. Monk, and I wanted to do a quick video for more simplifying radical expressions, because I know you guys are loving this stuff. So I've got 4 examples, and then the sub will give you the assignment. Here is number 1. Okay, so the first thing we want to do is look to see if we can simplify the fraction underneath the radical. Okay, simplifying that fraction, is there a number that goes into both 27 and 12? And the answer to that is yes. What, 3 goes into both of those? So let's write that down. We're going to have square root, and 3 goes into both, so we're going to have 4 over 9. And then we have a cubed up top and an a on the bottom. Well, that a on the bottom is going to take away from one of those a's up top, so we're going to have a squared. Ooh, that should be an a. Squared. There. That's an A, if you're curious. Now, we're just going to finish this up. We can do the square root of 9, which is 3. And we can do the square root of 4, which is 2. And the square root of A squared, which is A. So for the first one, that first example, even though we have a fraction underneath the radical, you can just basically, you're doing the radical of the numerator, radical of the denominator, each piece you're doing the square root. And this one works out great because we get the square root to go away. We have 2a over 3 as our final answer. Now, let's take a look at the next one. We have the square root of 75 x to the 5th over 48x. So let's ask ourselves, is there a number that goes into both 75 and 48? And I do believe 3 goes into both of them. So 75 divided by 3 is 25. Look how that's working out for us. 48 divided by 3, I do believe, is 16. Boom. And then we have a single x on the bottom and x to the 5th up top, so we're going to have x to the 4th. Square root of 25 is 5. Square root of x to the 4th is x squared. Square root of 16 is 4. And look at that. It worked all nice and pretty for us again. I love that. Let's move on to number 3. Now, this is something a little bit different. This one's called rationalizing the denominator, which means we need to get the denominator so it no longer has a radical in the bottom. We don't like when there's a radical in the denominator. So in order to rationalize the denominator, we're going to do this little trick. Is that you take that radical in the denominator and you're going to multiply it. That's not very pretty. Let's try that again. Nope. Get rid of it. Okay. Take that radical 3, there it is, and you're going to multiply it radical 3 over 3, right? Because 3 over 3, or radical 3 over radical 3, is 1, right? So we're just multiplying by 1, not a big deal. But the square root of 3 times the square root of 3 is going to become the square root of 9, right? And the square root of 9 is 3. So that clears out the radical in the denominator. And then we have 3 times the square root of 3. Pretty sweet. But look at this. We've got 3 over 3. Ka-choo! Right? So now our final answer is just simply going to be the square root of 3. How lovely. How lovely. Equals square root of 3, final answer. And we're done. Yay, us. So now let's go on to the last one. The last one's a little bit more complex, because that's how I roll. We have to look for a way to simplify the denominator first. Okay, so right now we have square root of 12 times the square root of 12 x to the 3rd power. We need to simplify this down. Okay, so we're going to leave that square root of 11 up top. I can't do anything with that. But the square root of 12 times x to the 3rd power, we can break that down into this, right? We can break that down into 4 times 3 times x squared times x. Mr. Mach, why would we do that? Well, because we can now simplify that further. Because we can do, I'm going to leave the square root of 11 up top. The square root of 4 is 2, but I can't do the square root of 3. Square root of x squared is x, but I can't do the square root of x. So that's going to break down into this right here. Now, we don't like this. We don't. There's the square root in the denominator still, so we need to further fix this. So, moving along, back to my pen. We need to now do that rationalize the denominator, so we're actually going to multiply by that square root of 3x over the square root of 3x. Now, how did I choose the square root of 3x? Well, because it's right here. Right there. It's right here, right? So by doing that, I'm going to eliminate it out from the denominator, which is exactly what I'm looking for. So when I simplify this, and I'm going to come down here so we can continue to look at what we're doing here. We have the square root of 11 times the square root of 3x. That's going to give me the square root of 33x up top over, now I've got to have 2x times, now the square root of 3x times the square root of 3x is going to give me just 3x, because that'll be 9x squared. Square root of 9x squared is 3x. So we'll get our final answer, which is the square root of 33x all over 6x squared. And we're done. That's it. That's your final answer, because that number, that 33x, is trapped in the radical, and we can't unlock it, so there's no way that we can simplify it with the 6x squared. So that would be our final answer, the denouement. All right, so this little final breakdown of all of our work here. Get that? Can I oh, I can shrink that too. Look at that. Oh, that's pretty cool. Woo, where are you going? All right, so there's the final breakdown of all the work. The assignment will be given to you by the sub, and I hope this helps you.